Remember the movie Harry Potter and the Philosopher's Stone? One of the characters on this movie is Nicholas Flamel. Nicholas Flamel is one of the Headmaster Albus Dumbledore's close friend. It is mentioned in one of the scenes that he was the only alchemist known that is able to make Philosopher's Stone, a powerful substance that can perform many magic tricks such as transform any metal into pure gold. Now, Nicholas Flamel is actually a non-fiction character. He was an actual well-known French alchemist in the mid of 17th centuries.
Never die. I know what it means. The only stone currently in existence belongs to Mr. Nicholas Flamel, the noted alchemist, who last year celebrated his 665th birthday.
Centuries ago, civilization did not know science yet. In solving problems, humans rely on claims that have no basis for quantitative data and always use secret methods. It looks like sort of magic. How then can we move on to the science era? In chemistry more specifically, what event marks the beginning of data-based understanding? This experiment will try to demonstrate one of the powerful modern chemistry laws that marks the beginning of the science era in chemistry. It is Proust's law of definite proportion. Quick nature of science aspect. Law in science is the way scientists mathematically draw relationship in a natural phenomena or result of experiment. Proust's law of definite proportion states that in a given compound, the elemental ratio is in a fixed ratio. This means that in chemical reactions, what happens is that elements combine to form compound. No new elements are formed. This is already a huge paradigm shift. Back then, people believe that chemical reactions are random and can create matter out of nothing. With the right method, back then people believed that they can create entirely new elements from the reaction. In this experiment, we will try to heat the magnesium so it can react with the oxygen to form magnesium oxide. The mass of magnesium, oxygen, and magnesium oxide will be measured in 3 trials. According to Proust's law of definite proportion, the mass ratio for all 3 substances above will be the same for every trial. Tips for this experiment: you must rub the magnesium ribbon using sandpaper to clean it up from the rusting and any other contaminant. In this picture, you can see the result after the rubbing, and please don't touch it using your finger after you clean it, because your hands or your finger might have oil that can contaminate the magnesium again. Tips number 2. The function of the lid is to prevent the sample from escaping. You have to lift the lid later when the magnesium is ready to react with oxygen. You shall see when you open the lid, the magnesium will give a bright yellowish flame. Wait until the flame is completely stopped, and you will see your end product, a white ash of magnesium oxide. You can stop the heating at this point. This is the example of raw data collection table. The raw data collection must show the mass of crucible, the lid, and the magnesium before and after the heating. Using the raw data, you can calculate the mass of magnesium, and then the mass of magnesium oxide, then the mass of oxygen. This is the example of process data, mass ratio elements, and compound. You shall see that the ratio is around the same for each trial. which is 3 for the magnesium, 1 for the oxygen, and 4 for the magnesium oxide. However, is it really scientific to say so? Can we really draw a conclusion that the ratio is fixed for all trials when the number does not exactly show the same? How strong is our conclusion? According to the reference value, the ratio is supposed to be 3 to 2 to 5 for magnesium, oxygen, and magnesium oxide. The data shows 3 to 1 to 4. What possible reason causes this difference? How can we explain this difference using observation and logical thinking? Are there any assumptions that we make that can affect the result? You must create a sort of scientific theory to explain this. Please visit campwithchris.com to see some of the example of assumption that may help you give more scientific interpretations on your data.